Okay, chapter PE, number 2. So in this one, let's solve some inequalities that are harder than just linear ones. So linear ones, you can use sign analysis charts too, but really, you pretty much only need them when they're anything harder than a linear function. So there's a quadratic in A and a cubic in B. So in A, let's first get 0 on one side. So I'll bring the 9x over, and we get this. Now these two things, the original and the one that I just wrote, have the same exact solutions. So I'm just going to deal with the second one. Okay, well the second one, remember now, we're supposed to come up with a corresponding equation and solve that for the zeros, and then use that to help make the sign chart. So when I factor this thing, I'm going to get 4x minus 1 and x minus 2 is less than 0. And that's essentially my corresponding equation. The corresponding equation is 4x minus 1 times x minus 2 equals 0. Okay, now what I need to do is solve for the zeros. So either 4x minus 1 is 0 or x minus 2 is 0. So when I solve those, I'm going to get x is a fourth or x is 2. So let's make our sign chart. Here's a fourth, here's 2. Those are my x values. When I plug them in, I get zeros. So now we want to fill in the missing parts in between, or on the ends. So right here I could plug in x equals 0. Now you can plug it into the original if you want. I think that it's probably easiest for all the different numbers that you're going to plug into the factored form. If I plug in 0, I'm going to get negative times a negative, so that's a positive. In between, an easy number to plug in would be 1. So if I plug in 1, 4 times 1 minus 1 is positive, 1 minus 2 is negative, so it's a positive times a negative. That's a negative. And then if I plug in a huge number like 100, because it's to the right of 2, I'll get positive times positive. That's a positive. Okay, so now I've got that. The original question is, well, my modified question is, when is 4x squared minus 9x plus 2 less than 0? Well, this is the sign chart for this, right? So I'm asking, when is it negative? Well, it's staring at us. It's negative in this range right there. So it's negative for all the x's that are between 2 and 1/4. Notice I'm not doing the equals version because at 1/4 it's 0, not less than 0. It's not negative there. So this is my answer, and if you wanted to write it in interval notation, it would look like this instead. In B, we have x cubed, not x squared anymore, so it's a cubic. I noticed some students wanted to do this right away, but you can't, because if I divide by x, then I'm saying there's no way x could be 0, but maybe it is. So I'm not allowed to do that. So instead, what I'll do is I'll just factor. I'm not actually dividing by anything here. And then the x squared minus 1 will also factor. So x plus 1, x minus 1, all greater than or equal to 0. And so then my corresponding equation is going to be the same exact thing I just wrote, but equals 0 instead of greater than or equal to 0. Okay, so now let's solve that. So x is 0, or x is negative 1, or x is 1. So we can make our chart. Here's 0, here's 1, here's negative 1. When I plug those into, say, my factored form, we know those give me 0. Okay, so now let's plug in numbers, in between and on the ends. So if I plug in something over here, like negative 100, right, this will be negative, this will be negative, that'll be negative. 3 negatives multiplied together is negative. If I plug in something like a negative half, I get a negative times a negative, times a positive times a negative. So 2 negatives and 1 positive all multiplied together, that's positive. If I plug in 1/2, I'll just tell you, it'll be negative, but you can check that. And then if I plug in a gigantic number here, anything bigger than 1, I'll get a positive. Now, somebody asked in class, do they always alternate? And the answer is no, they don't always alternate. So you should check just to make sure. So going back to what we started with, we're trying to figure out greater than or equal to 0. Okay, So greater than or equal to 0 here, well, that's going to be all the positives and all the zeros. So everything from -1 up to 0, and from 1 all the way on to infinity. And I want to include the -1, the 0, and the 1 because those give me equal to 0, and that's that part right there. Okay, so I can write it like this. I can say -1 is less than or equal to x is less than or equal to 0, or x is bigger than or equal to 1. Or I can write it using interval notation like this. Bracket, since it's included, -1, 0. Union, remember that means or. And then 1 up to infinity. And again, the brackets are there because those are included.